Find the limit of the following function using the difference quotient. In the previous video, we had a linear function. In this example, we're going to do a quadratic function, power 2. Again, the light blue is to signify the original function given. The lavender is the function value with x plus delta x substituted in. So everywhere we have an x, we're going to replace with x plus delta x. Be very careful to use your exponent property first. In the upper right of your screen, x plus delta x squared, that just means there's two of them. Foiled out, we get x squared plus 2x delta x plus delta x squared. The outer and inner are both x delta x terms, so there's two of them total. Back over here to the left side of your screen, x plus delta x quantity squared. I've just rewritten that with our result from the top right. Distributing 2 very carefully, we get 2x squared plus 4x delta x plus 2 delta x squared. Distributing the minus 7, we get negative 7x minus 7 delta x. When you set up your difference quotient, be careful that the lavender component goes in the upper left, and that's all the terms here highlighted in lavender, minus the original function, that's the upper right. 2x squared minus 2x squared goes to 0. Negative 7x minus negative 7x also goes to 0. The remaining terms in the numerator are 4x delta x plus 2 delta x squared minus 7 delta x. Our denominator is delta x. Factor a delta x out of all three terms in the numerator, and that leaves behind 4x plus 2 delta x minus 7. Cancel those delta x's, and you have the limit as x approaches 0 for 4x plus 2 delta x minus 7. This term in the middle, because delta x is going to 0, will go away, leaving you 4x minus 7. 4x minus 7 is the derivative or rate of change for any x value of that original function highlighted in blue. The squeeze theorem. If your function can be squeezed between two separate functions, in this example, we have 3 minus x squared. The other function is 3 plus x squared. If our function is trapped between or equal to those two functions, you can apply a squeeze theorem, which is the limit as x goes to 0 of the left end, the middle, that's our original problem, and the right function, the upper function. If those limits on the ends have the same value as x goes to 0, both of these functions go to 3, and that squeezes in on your function, and its limit must also be 3.